At 2 o'clock, I'm gonna go to Julie's desk area and I'm gonna take the practice test. Because I think I'm ready. Yeah. Yeah.
You need my help? Okay, I'm not a waitress. I couldn't help it. I couldn't help it. You know what she said? She knew her job was to get people.
All right, we'll give you one more minute and then we'll take a look at these together. All right, and number 3, we have a rectangle and the perimeter is 29 and the length of the rectangle is 5. And we're looking for the width. So sometimes it helps to sketch a little picture to maybe get you going. So if we know we're working with a rectangle, we can start with the rectangle formula from the formula sheet. And now I'm basically just going to plug in the numbers that I know in where they belong. So I'm told that the perimeter is 29 and that the length is 5. And what I don't know is the width. So basically you should end up where there's only one letter you don't know. And that's the thing we're looking for. So I can go ahead and multiply 2 times 5 to get a number there, 10 plus 2w. Now this is called a 2-step algebra equation because it's going to take us 2 things to get rid of the 10 and the 2 so that w is by itself. The 2 is being multiplied by the w, so I have to divide to get rid of that. But if I divide by 2, I've got to divide everything by 2. And I'm going to make a fraction on the left-hand side, which is no fun. Nobody likes them. And so if you leave that division till the very end, you'll either not get fractions at all, or you'll only have a fraction in the last step. So let's talk about this 10. It's being added to the 2W. It's a positive 10. And so we're just going to subtract it and make 0 on the right-hand side. And if I do that on the right, I've got to do that on the left. And so 29 minus 10 is 19. 10 minus 10 makes a 0, and then the 2W comes down. And so now that I have to get rid of the 2 to get W by itself, 2 is being multiplied by W, so I'm going to do the opposite or inverse operation is division. And 2 divided by 2 is just 1, and so it leaves 1 W. And then 19 divided by 2 would be 9.5. And so the width of the rectangle is 9.5 meters. Now that's the longest algebra problem we've done today. Do I have questions at any step? Any questions? Any questions or concerns? You can put them in the chat. You can turn on your mic. All right. Well, if we go to number 4, we've got a triangle where all sides are equal. So it's going to look something like this. And the perimeter is 18. And so we want to know what are the lengths of the sides. And we've already said the sides are all the same length. And so there's basically 3 S's that are all the same length. And so the perimeter of this would be S plus S plus S would be one way to write it. Or if you knew the length of the side, you would just multiply it by 3 to get the perimeter. And so another way you could write it would be 3 times S. Just like for our square, we have 4 times the side because the sides are all the same and there's 4 sides. In a triangle, if all the sides are the same, there's 3 sides. So S plus S would be the same as 3 times S. And now I know that the perimeter is 18. So I'm just going to put 18 in for P. And now I'm left with one thing I don't know, S. 3 times S is 18. So I do the opposite of times by 3. I divide by 3. 3 divided by 3 is 1. So I just have 1 S on the left or on the right-hand side, and 18 divided by 3 is 6. Now I could check my work because I can literally come back here and put a 6 in for each of these. And I know that the perimeter of a triangle, I add 3 sides together, 6 plus 6 plus 6 is in fact 18. And probably something I should have said earlier, you can take and substitute back and your amount that you found to see if it actually equals the perimeter that you've been given. All right, questions on this one, equilateral triangle. I would recommend you know words like equilateral and isosceles for your test. Okay, number 5, we now have another triangle that's 14. And one of the sides of the triangle is 6, and the other 2 sides are equal. So again, maybe a picture would help. So the perimeter is 14. One of the sides is 6, and the other 2 sides are equal. Now, when I put that little mark on the side, that means these 2 are equal. So if I call this side S, then that means the other side is S also. And so for a triangle, we add the 3 sides together. I know that P is 14. And 2 of the sides are S's, and one of the sides is 6. Now, when I have S plus S, that's like having an apple plus another apple. I have 2 apples or 2 S's. And so I get to a point where I have one variable S that I'm trying to find out what it equals. Again, the 2 is multiplied by s, so I've got to divide everything by 2. In this case, it wouldn't produce fractions, but it's always a good idea to do that division last. And so I'm going to get rid of plus 6 by subtracting 6 from both sides. And I'm going to get 8 equals 2s. And you can see, just like I told you not to do, my work is getting really crunched. So I'm going to come over here and rewrite 8 equals 2s so that I have it where I've got a little bit of space to work. That's 2 times s. Trying to get s by itself. And so I'm going to divide by 2 because 2 divided by 2 is 1. Divide the other side by 2 and s equals 4. Now remember, I could come back here and I could say, okay, this s is 4 and this s is 4. And if I add these 3 sides together, I better get 14 or I've made a mistake. And 4 plus 6 is 10 and 10 plus 4 is 14. So there are ways to check your work and see if you've got the right answer. Okay, questions on that one? All right, last one is a circle. And we've got a circumference is 78, and this time we want the radius. And so we have to remember we have 2 circumference formulas, but since I'm given the radius, I'm going to choose the formula that uses the radius. The number I know is 78, and it equals c. So that means I need to come over here, and where I see c, I need to put 78. Now we know pi is 3.14. Or an approximation for it. So I'm going to go ahead and put that in there so that I can multiply those 2 together. And so if I take 3.14 times 2, I'm going to get 6.28. So this equation says 6.28 times r is equal to 78. So if I want to figure out what r is, I need to get rid of that 6.28. It's being multiplied times r. So I'm going to do the opposite. I'm going to divide because 6.28 divided by itself is 1. So I'm left with r on the left-hand side. Whatever I do to the right, I have to do to the left. And then it's just a calculator problem. 78 divided by 6.28. If I'm going to round that to the nearest 10th, this first 4 is in the 10th place. I look next door and it's also a 4. So that is a lower number, and I round down, I keep this 4. And so my answer is 12.4 centimeters.
When would you round up? It's 5 and above?
Yes, when it's 5 and above, you round up. So let me write this number. This is what the calculator says. I don't know that you guys can see that very well on the screen. So this is the long number the calculator gave. And so if I'm rounding to the 10ths, I identify that digit. And that means this is the last number I'm going to have when I round. I'm going to have something in this position and nothing else. And so I look next door. It's a 4. So this 4 remains a 4. If the number next door was 5 or higher, then this number would raise to 5. But 12.44 is closer to 12.4 than 12.5. And so that's why we would round it that way. Any other questions about this problem or any of them?
Yeah, I'll probably be back.
Yeah, I got a question. So the answer, 12.4 centimeters. It's
What? Yes.
okay, so 78, the circumference, it's divided by twice pi.
Yeah, he should have it all.
It's divided by twice pi. Is that what you said?
Yeah,
Yes. So
okay.
because I took 2 times 3.14, and since I can multiply those
Oh.
together, that's how I got 6.28.
Okay,
So that's the twice pi, and it's being multiplied by r. And so to get rid of multiplying by that, I divide by 6.28. And whatever I do on the right, I have to do on the left also. And so in the end, you actually said it perfectly. You're dividing the circumference by twice pi.
I was just trying to simplify it. You're right, I need to work on my, my mathematical, I need to work on my writing. So
Well,
I don't- that's all.
Don't jump steps, don't jump steps.
That's very, very common for, because you get to a point where you can do some of it in your head. And so you start doing some in your head, and then you get to a point where you can't. And then when you start writing things down, it doesn't always come out the way it went in. So the best policy, I mean, obviously I'm at a point in my mathematical career where I could do a lot of this in my head, but I still write it out too.
Okay,
Obviously to show you. So yeah, if you take it
That makes
step by
sense.
step, because what happens, some students is they take this 78 and then they put it in for R because they didn't write down the formula. And if you write it down and you see it, then you're less likely to put the 78 in for R. You're more likely to put it in for C.
okay.
So it's a common issue, and it's just one of those, the more you write down, typically the better you'll do. But we like to do lots in our head or not expend a lot of energy writing, and you just got to find a balance for that where you're able to get the problems right with what you're writing down. Good questions. Anyone else? Okay, back in our packet then, these problems are ones that we just did. You are more likely to see a perimeter problem going this direction than the other way. In other words, you're more likely to see a problem where they give you the perimeter and you have to go back to a side length than you are to be given the sides and asked the perimeter. So keep that in mind. This would be a great paper to keep, and even, try and practice them another time if you're not quite solid on them. The next, if we go back to the packet, the next page in the packet looks like this. It says C, the letter C, and solve each problem. On the bottom, it says page 123. So it should be the next page in our packet. This has some other variations of problems on them that would be related to perimeter, but might look a little different. And so I want to take a look at some of these. So for example, if we look at number 8 together, it says write and simplify an expression for the perimeter of the triangle. And as you look at this triangle and its side lengths, what do you notice that's different than what we've been doing? If you're trying to read this off the board and it's too small, let me just make it bigger here. What's different about that than what the problems that we've been doing?
It has an extra S.
Okay, there's lots of S's up there. Do we know any of the side lengths?
Yes.
Do we know the actual number? Can you say like this side is 5? Do we know an actual value for any of the side lengths? I see someone shaking their head yes. What's the lengths of the sides?
2, I guess, S plus 2.
Okay, it is. And the point I'm getting at, you're right. It is S plus 2, but we don't know the exact number. We don't know if this side is length is 10 or 20 or 85 or 4. All we know is if I knew what S was, I'd add 2 to it, and that's what it would be. And this side length here is S, and I don't know what number it is, but if I knew what number it was, like if this S was 5, then this side would be 5 and this side would be 7. But in actuality, I can't really say, we're not gonna be able to get a number like the perimeter equals 10 because we don't know what some of the sides are. And that's why it says, write and simplify an expression for the perimeter. And so we're still going to start the same way. It's a triangle. And so we're going to start with the same way. We're going to start with the perimeter formula. And remember that perimeter formula means just add the three sides together. And so we're going to have S plus S plus S plus 2. Because that's the 1, 2, 3 sides of the triangle. And now this is a little more algebra. S plus S plus S is like having an apple plus another apple. And if I have an apple plus an apple plus an apple, I have 3 apples. And here I have 3 S's.
Put P equals S times 3.
Yep, that'll work. So if you put P equals S times 3, you still need the plus 2 on the end. So if you look at what you said here and what I wrote, the only difference is I put the 3 in front of the S. And if it's a multiple choice question, you're always going to see the 3 written in front of the S. But S times 3 is equivalent to 3 times S. And so that's probably for some of you a little bit of an unsatisfying answer, but that's actually the answer, because it says write and simplify an expression for the perimeter. And the expression would be 3S plus 2. And that's all you can do. So this would be an example of combining algebra knowledge and the perimeter and geometry knowledge together to get an answer that's not numeric. Because until you know what S is, you can't do anything more for the perimeter than that.
You have an extra copy of the packet? It's outside. It's outside.
I'm in front.
All right, questions about that? If we look then at number 9, it says, what is the perimeter of the triangle in problem 8 if S is 8? And there's a couple ways you can do that. You can go back to our picture. And let me change colors. You can say S is 8. S is 8. What's S plus 2? Good. I heard it here in Paige. If S is 8, then 8 plus 2, that side is 10.
Oh.
You just take what we're given and add 2 to it to get 10. So if S is 8, the perimeter, I can add these 3 numbers. 8 plus 8 plus 10. 8 plus 8 is 16, plus 10 is 26. Or the other way I could do that is I could say, I know that from the first problem, perimeter equals 3 times S plus 2. And so I can put 8 in for S. 3 times 8 is 24, plus 2 is 26. So I get the same answer whether I use the picture or whether I use what I calculated in number 8. How's that feeling, everybody? Good. Got a few. I have a thumbs up here on Page. How are we feeling about that if you're online or in Flag?
Nice.
Okay, thanks, Brittany.
Sure. Good thoughts. We know how we're doing. That's part of what teachers need. They need that.
All right, so you try number 10. The picture shown, that's the picture over here on the right. the length is twice the width. So let me write this a little bigger. The length is twice the width. And so they're wanting you to write and simplify an expression for the perimeter. So number 10 is just like number 8, except it's a different formula because you're starting with a rectangle this time. So I'm going to give you a minute to see what you can do with this one. All right, I'm going to move to, I'm getting too squished here, so I'm going to move to another piece of paper.
Do you want to take a break or we'll do that?
Yeah, we're going to discuss this one and then we're going to take a break.
I remind you.
Okay, so basically the picture is twice, the length is twice the width. And so we know this formula. And I can take and put in for L whatever L is equal to. And L is equal to 2W. So I can take this L and I'm going to replace this L with 2W. And so the perimeter 2 times 2 is actually 4W plus 2W. And 4, that's like 4 apples plus 2 more apples is 6 apples or 6W. That would be the way to do the problem completely from the formula. And if that's a little shaky for you, let me show you another way to kind of logic through it that might help this make more sense. In this picture, I can put a W over here because these two sides are the same length. And I can put a 2W here because if this side is 2W, so is that side. And we know that you can find the perimeter of any shape by adding the lengths of the sides. And so I have 2 W's, 2 more W's, and then another W and another W. And if I just count all the W's, 2 W's plus 2 W's is 4 W's, plus another W is 5 W's, plus the last one is 6 W's. So in this method, I'm using the formula. And in this method, I'm using the picture.
So what do we want to have happen? Okay, you want to have both or?
So thoughts on that or questions? Both the nice thing about math and the curse about math is a lot of times there's more than one way to do something. And most people think better either geometrically or they think better algebraically. And typically you're stronger in one or the other. In other words, does seeing the picture make more sense to you? Or does chugging through the formula make more sense to you? And if you like chugging through the formula, you're probably more of an algebraic thinker. And if you like looking at the picture and visualizing it, you're probably more a geometric or a visual person. And so it's good to know your strengths. If you feel like you're more of a visual person, then when you get a math problem, you should always kind of sketch something out, draw it out and see if you can just kind of logic through the visual picture. If you're stronger algebraically, then when you have a problem, you should always try to go to the formula. And it's interesting as I tutor students, I had a student who just came in last week and he is a total algebra person. The visual pictures just really don't do anything for him. They don't help him learn. But if he says, if you can just put it in a formula, I can figure it out. And so think about how this problem makes sense to you more. And that's probably your strength. And if you're a visual person, then when you have math problems, you should try to sketch things out. And if you're more an algebraic person, you need to make sure you really know you work with those formulas. Okay. All right. That might be enough brain stretching before break. So it is about 5 minutes after. So we will take a break till 2:15. Let's give your brains a rest for a minute. If you have not filled out the sign-in sheet, please do so. I'll put the link back in the chat again.
Which screen do you guys like? Bigger or this one?
I like them both.
That doesn't help me.
I have them both up.
This looks clear, but this is bigger. Which one do you like? Anybody? Come on, opinions.
I follow those like this.
All right, break till 2:15. Fill out your sign-in sheet if you haven't yet.
Do you like the big one? You like that one? When I came in, it was both. Now it's trying to get it on.
Curtis, which one makes more sense to you?
Or if you can minimize the screen some kind of way, you gotta be Zoom up. You gotta go back to your student. We have that tablet. Oh, yeah, that's the way too. Oh, did you? Yeah. Those little mints.
Yeah.
Taking the whole test before.
But so that's.
No. Maybe be bad.
Sweet, yeah. What the? It's under the second.
Can I sign in with your tablet? Hold on, I need that screen.
Oh, they got good mints.
They do, they're shy. No, you did you.
It's. So that's. I'm gonna sign in on my computer. Because I have. Yeah. I think I've seen this packet. I think I have this packet in my old stuff. I was trying to look at it.
Working on it. We'll put it here in the class. Let's go back to the silence. Last day on time. I like back in the day.
No, this is on the test.
Oh,
This is on there, and this is where I bombed, I'm pretty sure. Cause I couldn't remember the formula, you know, and when you go in there, they just give you,
a question.
you know. You go in there and when you put on tests, you go into you know, it's a really small and there's like only like 5 or 6 people's lives in some real small areas, you use cameras and everything.
Dang.
And then the person logs on for you, and after they log on, and then
Did you
it's,
try?
and then when they tell you whenever you're ready, and it's up to you to like select it. So once you select it, that's when it starts going.
No.
And it's just like, and I'll tell you, hey, like you have that free research and sometimes it's over. And then, so. I guess there's like 3, I think 2 parts to that. 2 parts to the test. And then, actually, I think there's 3 parts to that. But they're all timed differently, but they're all in like a 2. And you gotta sit there.
Right.
Like they'll give you a break time, like maybe like a 5-minute break session before you start your next
Mhm.
lesson after that. Yeah, but you can't leave, gotta stay in there and they
Yeah.
watch you and they give you like a paper like this with a dry erase marker just for like your own like notes.
Doodles.
Like, yeah. Other than that, you get nothing else to do. You can't even take drinks. You can't take.
No concentrated?
Phone and nothing. They make you put all that in like little.
I think I did
box
submit.
words.
Sorry.
Yeah.
It's really, I think it's like top notch. But to go to NAU. You go in.
Another foot in the door.
Mhm. Yeah, it inspires you. I feel like this is,
That's what's up.
it's like meant for you to want to do it. Yeah, the test was like. Just a lot of like lists. And a lot of, and we haven't gotten into it yet. Yes. But we will, I'm hoping, it's gonna be graphing, geometry.
Like that.
Yeah, it's fun. It's the formulas.
It is. I know.
I don't know.
Gotta remember all the parameters.
But I'm not too sure if they do, I think they do, they might give you that little, that sheet she's talking about, that gives you the formulas on how to set it up.
Right.
They give you that, like the content, the table of contents for algebra or for math,
That's pretty.
they
cool.
give it to you.
That's
yeah.
good.
So that you know, other than that. I think anything.
It's all practice. It's ginger. Yeah.
I think I bombed my test because I waited too long, because after I felt like I was ready. to take the
You
test.
waited a minute?
No, like it took them a long time to get me like a voucher. To get me
All
to pay
set
for the
and
test,
everything?
to get me to go, like, because once you gotta like prove that you have to take a your pre-test all over, you gotta get your score all over again. And because like, the school doesn't pay for it, it's like there's a scholarship. They have to pay for it, you gotta send that, your results to the scholarship, and then they send you back this, this code, this verification code that you use
That's pretty.
so that when you go and register for the actual test, when you're registering for it. And you like select your, the place that you're gonna go. I always just spend any year. I think that's the only place that we do it. But yeah, and then that voucher that they give you, that code, is always like active, so we enter it, it'll just pay for the test. And then you show it.
That's dope.
That's how it's done. But other than that, I think you can pay for it yourself.
Yeah,
But whenever you feel the need that you're ready, like that's.
I know, I'm not even ready yet, I'm like trying to take.
Yeah, so that whole process of like trying to get the voucher and then like take the test, get the voucher, and then send the voucher. And then it was like 2 weeks, man. And like
Right.
all of it just kind of like I forgot. Then when I got there, I was all panicky, like, oh God, I can't read this. You can't remember
That's
this.
crazy.
So hopefully a second go around refreshes everything and don't forget this. But it's funny. It's funny because I bonded like 4 points.
Like how many? 4 points? Yeah.
Dude, like I felt so bad. I was like, dang it, man. And it was funny because like the pre-test said that I was 4 points over, and then when I took the test, I was 4 points under. So it's like, dang.
Think they computer whooped you on purpose?
I don't know, dude. I really did. That was my score.
Brown man.
My score, man, was like 4 points up, and then I went to take the test and it was 4 points back.
She ain't passing.
I was like, oh my God, I was so devastated. That's kind of why I didn't get into math for a while. I was like, you didn't do that all over again.
I had about 120 for y'all.
See, how it's hard, huh?
Language arts is hard when you have to write the essay. You gotta do the essays.
Thank you. Usually tells me. All right, if we can come back to class. Just in case you have a panic attack about taking a calculator to the GED.
4 points over, then 4 points under after and it was actually really.
The good news is they will provide a calculator on the computer for you. So that won't happen to you, hopefully. All right. I did hear a conversation in Flag about, I think you're talking about GED ready scores and getting a ready score that was above the passing zone, but then struggling to get a passing score on the test itself. And I was in a webinar where some teachers were saying they had noticed that it seemed like some students didn't do quite as well on the GED math test as they did on the GED math ready test. And we talked a little bit about why that might be. And GED wasn't willing to acknowledge that really happens a lot. But some of the things we talked about are your GED ready test is a half-length test. And so it's half the length of the full GED. And so there can be a fatigue factor potentially that impacts that, as well as anxiety. It's just a longer, it's twice as long. And so I would encourage you as you're taking these GED ready tests, particularly for the math, you want to be a healthy margin comfort level above that minimum passing score of 145. So, and unfortunately, math anxiety can play a factor. And the idea is we want you to go in as confident as you can so that you can do as well as you can on the test. Any questions or thoughts about the GED math test?
Can I add something to that if I could?
Yeah, sure.
A good night's sleep. I wouldn't study the night before. If you don't know it by then, you don't know it. You just cram your brain full of stuff. A nice restful sleep. Don't do the math that night. This is my experience with the GED. And eat a lot the day before, especially protein. Eat a big dinner.
Not a big old greasy burger.
No, no.
With a side of fries.
It's gonna get sluggish and go to
Glass
sleep.
of wine and half a glass.
But yeah, don't cram it the night before. If you're not ready by then, it fatigues your brain.
And then the other tip I would give is make sure you know how to use this calculator. Most students struggle with fractions, and this little calculator can do all that work for you. So as you get ready to take your GED, I'd really encourage you to sit down with one of the teachers, whether it's in person or via Zoom, to really make sure you know how to use the calculator, particularly for fractions. Okay, I don't know if you can hear that. We have some kind of alarm going off in Page, but hopefully they'll figure out what's wrong here pretty quick. All right, so we ended with number 10. I showed you a couple ways to get that perimeter to 6W geometrically as well as with the formula. And then if you look, number 11 says the width of the picture in problem 10 is 10. Find the perimeter of the picture in order to frame it. Well, if we use our number 10 answers, we found that the perimeter is 6 times W. And so now they told us that W is 10. And so if the perimeter is 6 times W, that means that wherever we see a W, we can put in the number 10. And so the perimeter is 6 times 10, or the perimeter would be 60. So that would be number 11. That would be using our formula. This would be our more algebraic answer. If we were more visual and geometric, we could actually go all the way back to the original picture we were given. And we could say, okay, I know W is 10. And then that means 2W is 20. And so my side lengths are 20, 10, 20, and 10. And if I add those all together, 20 plus 20 is 40, plus 10 is 50, plus 10 more is 60. So again, it doesn't have to be one right way always to do the problem. So this would be a more geometric or visual way to do the problem. Up here would be the more algebraic way to do the problem.
So the answer is 40?
The answer is 60. Right here, right here. Are you getting 40 by adding 20 and 20?
Yeah.
Okay, on your perimeter, you got to add all 4 sides. So you'd add 20 plus 10 plus 20 plus 10. And basically you need to add these 2 10s in, and that's how you get to 60. Make sense?
I get it, I just don't remember it. Yeah, I have 20L times 2 equals 40 plus 10W times 2 equals 60.
Can you read that to me again?
20L times 2 equals 40 plus 10W times 2 equals 60 perimeter. I don't know why I put that.
Well, you got 2 equal signs.
So the diameter is 10 cm, right? 10 centimeters.
The width is 10.
Yeah, the width is 10. So that would mean the perimeter is 10 times 4, wouldn't it?
Now, if it was a square, it would, but it's a rectangle, remember?
Yeah, okay.
So I've got a width of 10 and a width of 10, but then the length is twice the width. And that was given way up here in the original picture. The length equals twice the width, which means that once we know the width, we double it to get the length. Or in this picture here, if the width is 10, then we double the width to get 20.
We're on number,
11,
number 11, okay.
where basically it's telling you for problem 10, the width is 10. So we're
You know
using,
what, I'm sitting there looking at that circle inside the square to the right. My vision's, yeah, I'm a little
you're
bit
on
off.
the next problem. That's why. Okay, that helps. You're just advanced. You're just advanced. So we're getting there. How about that? I wondered when you said diameter, I was trying to figure out where you got a diameter out of that rectangular picture, but that is where you got it. So
Okay,
number 12, let's take a look at it. So it says the illustration shows a circle inscribed, and inscribed just means that the circle touches each of the sides of the square in one place. So inscribed means drawn inside, but it also has to touch each side. And so it says, what is the circumference of the circle? Okay, well, this is a straightforward kind of forwards problem. We want to know the circumference. We're given the diameter. So the circumference equals, this is a cross out, not a 2. Circumference equals pi times diameter. This is why your math teachers also told you never to work in pen. And exactly what I'm doing, because you can't see it if I work in pencil. But anyway, so we know D is 10, so we're going to put that 10 in for D. I know the pi is 3.14. And so I'm going to multiply to find the circumference. Remember, we talked about the circumference is a little more than 3 times the diameter. And if you take 3.14 times 10, you're going to get 31.4.
yeah, you gotta move the decimal place.
Exactly. When you multiply, the shortcut for multiplying by 10 is you simply move the decimal one place to the right. Or again, you'd have your calculator and you could calculate it. Okay, and now I understand where you're getting 40 from, because the second question is, what's the perimeter of the square? Well, if you look at this diameter, that's 10, it's the same length as this side of the square. And so that means the side of the square is 10. And if it's a square, that means all of the sides are 10. And so again, for my algebraic people, the perimeter is 4 times the side length. And so the perimeter is 4 times 10, or is 40. Or for my visual geometry people, all 4 sides are 10, and 10 plus 10 plus 10 plus 10 is 40. So you were correct with your 40, you were just on the wrong problem.
Yeah, correct. No, you're right.
Glad we solved the mystery. All right, any questions about this problem? This one is kind of the straightforward problem. You're finding the perimeter and finding the circumference, but using information from the drawing. Okay, number 13 is going to be a bit of a challenging one. If you weren't with us last semester, or you don't remember the Pythagorean theorem. When I taught Pythagorean theorem, I said, this is a piece of information that I can assure you, you will have on your test. And I'm going to go through it. I mean, I'll show you it today, but I'm not going to do a full teaching on it. And that's something we'll revisit at some point for a full teaching. But basically, so it says the illustration shows a square inscribed in a circle. So that means the square is drawn inside the circle. Inscribed means inside, would be a way to remember that word. And we're looking for this diagonal S. And this triangle is what we call a right triangle, meaning it has a 90-degree angle. And so we're trying to find the length of side S, and I'm going to draw this picture over here. So it's a little bit bigger and I have some room to write. And I'm going to put X instead of S just because S looks like a 5 a lot. And the Pythagorean theorem, anybody remember the Pythagorean theorem? It has A's, B's, and C's in it. Anybody remember? Those of you who were with us last semester? Remember? Huh? Nope, those are angles. Those are angles, and we're talking about sides. The Pythagorean theorem says A squared plus B squared equals C squared. It only works in right triangles, triangles with a 90-degree angle. And these two sides are called the legs, and they're A and B. And this side is called the hypotenuse, and it's side C. It's ringing a bell for anybody from last semester. I'm not sure how many of you were here last semester or from high school. Okay, got a thumbs up from one person. So when you don't know the third side of a right triangle, you can put in the lengths of the legs to find the hypotenuse. Now 5 squared, this will be a good review of exponents. 5 to the second power means 5 times 5. It doesn't mean 5 times 2. And so this is 25 plus 25. Which is 50. This says C times itself is 50. So for example, 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. And 8 times 8 is 64. And so 7 times 7 is 49 is really close to 50. So this C is going to be really close to 70. And what you do is you end up taking what's called the square root of 50. And we showed you how, if you were here again, if you were here last semester, we showed you how to do that. But basically on your calculator, the square root key, there's the 7, and next to the 7, it says x squared. And above that in green, it has a square root symbol. So I push the green second key and this key, and it puts that square root up in my screen. And I say, I want to take the square root of 50. And you can see that number is almost 7. It's 7.07106 and so on. And if we look at our answer choices, this one's a multiple choice, and it says S is equal to 5, approximately equal. See how the equal signs are kind of wavy? That means approximately. So 1 says S is approximately 5, 2 said S is approximately 6, and 3 says S is approximately 7. And so that would be the best answer. And so then it's asking for the approximate perimeter of my square. And so this side here is approximately 7. It wants to know the perimeter of the square. And if each side is about 7, I take 4 times 7 and I get 28 centimeters. So number 13 would be an example of how they can take a couple different math concepts and put them together. If this problem were on the GED, it probably just would have shown you the picture and asked what the perimeter of the square was. So you'd have to find this side and then find the perimeter. And so I don't do this to freak you out, but Pythagorean theorem is a topic that we have covered and we will cover again because it's a real important concept in mathematics that's actually used a lot in the real world. So it's a good one to know, not just to pass your test. All right, if we go down to number 14, it says the illustration shows the plan of a flower bed in a park. The shape is a half circle or a semicircle. And so what this problem is doing is saying maybe you know how to find the whole circumference, but do you know how to find half of the circle? So we've got D is the diameter, so we don't have a set number for the diameter. Can anyone tell me in words, not even in math necessarily, in words, how would you find the portion that's in yellow here?
Well, we know that a full circle is 360, so half of a 360 would be like
180.
Yeah, so we know that's 180, right?
Well, you're exactly right, but you're answering a different question. In degrees, this would be 180 degrees because a full circle is 360 degrees. So you've got the right idea. We've got half of something. If we knew the whole circumference of the circle, we could just divide it by 2 to get the distance around half the circle, right?
We can do the formula for circumference if we knew what D was.
Right, exactly. And then
Divide that by 2.
exactly. You guys have got the exact right thing. So the yellow part, if we took the formula for circumference and divided it by 2, would you agree that would give us the yellow distance?
Yes.
Okay, so we've got the yellow distance, but we are trying to find the distance around the semicircle, which means we are also going, I think this problem is implying, if we're going to fence this, we're going to have to fence this part too. And so around the semicircle is pi d divided by 2. What do we have to add to it to get the fencing for all the way around the shape? Here in Paige, she said, we've got to add another fencing length that's the length of the diameter. And so as we look at our choices for A, 14A, which one's the right one? 1,
2.
2, exactly. So we just took something we knew, the circumference, and we figured out we only have half of it. So we took the circumference and we divided it in half so that we got only half the circle. But now we need a little more fencing to go along this straight piece. And so we have to add to that whatever the length of that diameter is. And so again, maybe that's a really unsatisfying answer to you because it's not like 14 feet. But once we know the diameter, we could calculate what it is. But these kinds of problems are asking just for an expression for you've created a new formula. You've created a formula to find the perimeter of a semicircle. Thoughts? Okay, so it says, well, we're not going to do this. We're going to do 3.14. So it says find the amount of edging needed to surround the flower bed if D is 49 feet. So now they're going to tell us this is 49 feet.
I'm gonna go. Thank you.
And so if that's 49 feet and that's D, everywhere I see a D, I can plug in 49 feet. And so I can take 3.14 times 49 divided by 2. That gives me the yellow portion of fencing or edging. And then I have to add to it the length of the diameter to get that straight edge here. And that may look really yucky, but that's a problem you can just plug in the calculator. You can take 3.14 times 49 divided by 2 and add 49. So we need about 126 feet of fencing. They said to use pi equals 22/7. I don't think you'll ever be asked to do that on the GED. So I'm going to flip it to 3.14.
So you just find basically find the circumference and then divide it by 2?
Exactly. You find the circumference, well, plus a little more. You find the circumference and you divide it by 2, but that only gives you the amount of edging for the yellow portion. And then you have to add in the diameter to get the straight portion. That makes sense?
Yeah, it makes sense.
Cool.
Because you remembered it was a flower bed,
Yeah.
not just the shape. It's
Yeah.
actually like a bed. So you want people to step into it.
Right.
Exactly. Okay, so number 15 is asking you basically to do the same problem several times. So we're going to do the problem together once, and then we're going to let you do it the remaining times to see how it feels to stretch those wings yourself. Okay, so Bill wants to fence in a rectangular space in his yard to make a safe place for his children to play. He has a total of 120 feet of fencing. This is something my husband would do. I have this much fence, and so we are only going to use this much fence, and we're going to figure out how big we can build it with what we already have. Assume that he uses all of the fencing. Calculate the length of the play space if the width is, and so this is actually 4 different problems. So the first problem we're going to do is the width is 25 feet and the perimeter is 120, and we have a rectangle. So for you visual people, let's go ahead and sketch this out. So basically, he doesn't want to buy any more fencing. He loves his children. He wants to keep them safe, but he ain't buying any more fencing for this project. So we need to figure out what these 2 side lengths will be so that we'll use all the fencing. Because like my husband, he doesn't like to waste anything. And if he uses all the fencing, he'll make it as big as he can for his children. So there's a picture and we're trying to find the length. So one way to begin this problem is to say, well, this is something I know. I know that a rectangular shape has the perimeter 2L plus 2W. What am I going to put in for P?
120.
Exactly, because that's what P is equal to. I don't know L, so I'm going to leave the L. And what am I going to put in for W?
3/5.
Yep. And so now we have an algebra problem. we have one thing we don't know, and that is what's the length. And so I can see that I can multiply 2 times 25. So I'm going to do that. So I get a number, single number here. And 2 times 25 is 50. So now I have a 2-step algebra problem. I've got to get rid of the 2 and I've got to get rid of the 50. I'd suggest getting rid of the 50 first. Just as a general rule, you want to divide last because division creates or can create fractions. So the opposite of plus 50 is?
Subtract 50
Yep,
gives you 70.
70 on the left, 120 minus 50. 2L comes down. And 50 minus 50 is 0, so it's gone. And now I have 2 times L is 70. So that means I'm going to do the opposite of times. I'm going to divide. 70 divided by 2 is 35. And so if he makes his fencing for his play area 25 feet this way, it can be 35 feet long. And he will use all the fencing that he has. Okay. So your job now is problems B, C, and D are the exact same problem, only this time he's only going to make it 20 feet wide. And remember, he has the same amount of fence. And C, he's going to make it 15 feet wide. And he has the same amount of fence. And same thing for D, 10 feet wide, and he has 120 feet of fencing. So I'm going to leave you here for a few minutes. I want you to see what you get for your answers for B, C, and D. And there's not very much room on that piece of paper. It'd be a good idea, probably, if you did this on another sheet of paper, but you can all make that decision for yourself, but see what you can get for an answer.
Oh, right, you have read, yeah. Does he go back? Wait, what am I doing? Yeah. I'm sure EP there.
William? Yeah. Could you, no. Come up with the. Tell you the link to our YouTubers.
Okay, give me another minute and then we'll go over those. Okay, if the width is 20 and the perimeter is 120, that means I'm going to put the 120 in for P and the 20 in for W. I can multiply 2 times 20 to get 40. I need to get rid of that 2 and get rid of the 40 so the L is by itself. I do the 40 first. I subtract from both sides. And then 2 times L is 80. So opposite of multiplication is division. And the length then would be 40. So my first length was 35 feet. My second length for part B would be 40 feet.
Zero.
Yeah. Or, you said 11, with the 0.
We have any questions on this second one? Okay, if I go to the third one, again, I start with the same formula because it's still a rectangle. And I'm going to put 120 in for P and 15 for W. I can multiply 2 times 15 to get 30. And now I have a 2-step equation. I need to get rid of the 2. I need to get rid of the 30. I can subtract 30 from both sides. 120 minus 30 is 90. 30s are gone on the right-hand side. And now I need to divide by 2.
The thing that I've always found
Sorry, guys.
amazing about chemistry, it's an entire field.
Sorry about that.
That's all right. First, I thought somebody was talking to me, and then I realized he wasn't talking about math. All right. So we get 45 for this one. Questions on C? Okay, I'm going to turn my paper here to do D. So I start out with the same formula. I'm going to put in 120 for P, and I'm going to put in 10 for W. I can multiply 2 times 10 to get 20. And then I'm going to subtract it off. And divide by 2. And L is 50. Now for you visual people, we kind of went around the corner on my page, but if you notice in A, B, C, and D, the length of the width is getting smaller each time. And as the length of the width gets smaller, the length increases from 35 to 40 to 45 to around the corner to 50. And so basically, if you think about it, if your perimeter, your fencing remains the same as you adjust if you make the width smaller, then that's going to leave more fencing for the lengths. Or if you make it shorter, it'll make, or make it larger, it'll make less fencing left for the length. So question is now, there's a kind of blank screen. Let's get some feedback. How are you feeling about these problems? Remember, if you go to the very top of your screen till you get this menu, or you go down to the bottom of your screen and you can choose annotate.
I'm gonna show of hands of how you guys are doing on these problems. Pretty good, or show of thumbs. Thumbs, Eddie? Yeah, cool.
Good.
Leah?
No one wants to draw on my board?
We got one come see, come saw. And we got 4 thumbs up. We're waiting for one to weigh in. So-
Okay. Oh, Robert, someone's going to give me a picture. There we go. Thank you.
Come on. You're
Now
so
give me my
back.
nose and some eyebrows. Okay, so we are about out of time. And I'm going to push back the very last part of perimeter then to next week. And so if you look in your packet, you should, I think, only have 2 pages left. I only have 2 pages, so hopefully you only have 2 pages left too. And so the last thing, and it said, don't let complex perimeter problems scare you. They're really not that complex, and actually once you see how to do them. And so basically we're going to be looking at shapes that might look like more the floor plan of a house, the footprint, the foundation of a house. And how do we figure out perimeter for there when we are missing some pieces? And these are more kind of like little logic puzzles. And then the last page is we're going to start looking at shapes that have, for example, a track that has a rectangular shape with half circles on the ends. Or again, things that have a few given measures, but you've got to kind of noodle out and figure out what the others are in order to find the perimeter. So we're going to be looking at different shapes and how to find the perimeter around them when we start putting pieces and parts together. And then we will be finally done with perimeter, and we're going to move on. Actually, you should have more pages in your packet, because you should have area as well. So there should be more. All right. Any questions for Write It? So we're gonna hold for today. I'll be on for just a couple minutes if you need anything, but I hope you have an awesome rest of your, what is today? Wednesday. And we will see you next week.
Thank you.
Thank you.